In this lesson, we're going to be looking at how to simplify radicals and square roots. So first we need to look at some vocabulary. The first thing we need to talk about is what is a radical. Okay, our square root sign here, that it kind of looks like a division sign, is our radical. And if you look at this example, the symbol here, we call this the b root of a. Whatever that small number is, where b is our root. It could be the square root. If there's no number there, there's an understood 2, it's the square root. There's a 3, it's the cube root. And then from there, if there's a 4, it's a fourth root, a fifth root, and so forth. Then our next vocabulary is called the radicand. That's the number that's up under the symbol. Okay, here in this little problem, it's a. But when we get in here, we're going to be using numbers. Okay. We should know what an exponent or a power or an index is. That's that small little number that's above a number that we raise a number to show multiplication. So here in this example, 8 squared, that power or exponent of 2 tells me to multiply 8 by itself 2 times. 8 times 8 gives me 64. So then what is a square root? A square root is when I multiply a number by itself so many times. So if I have 4 squared, if I'm looking at multiplication using a grid, I have 4 spaces going vertically, and then I have 4 spaces going horizontally. That's multiplication of 4 by 4. And if I were to make a grid out of it, I would get 16 spaces, or 16 little squares. So 4 squared, or 4 times 4 is 16. But we also know that we can multiply -4 times -4 and also get a positive 16. So we got to be very careful. When we take the square root of a number, we get the positive and the negative number out of it. Okay, perfect squares. These are something that you're going to need to have memorized. Okay, our perfect squares, here's a few of them. 2 squared is 4. 3 squared is 9. 4 squared is 16. Because these perfect squares here, 4, 9, and 16 are all perfect squares. Those numbers are going to help us in a minute simplify these radicals. So 2 squared, I'm just going to make a list, is 4. If you need to make a list and write them down, then do that for right now. 3 squared is 9. 4 squared is 16. 5 squared, 5 times 5 is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196, and 15 squared is 225. You need to know all of these. You should have all of these memorized. Now, in a minute, we're going to be taking the square roots. So if I say, what's the square root of 25? What number times itself gives me 25? 5 times 5. So the square root of 25 is 5. If I say, what's the square root of 121? Well, what number times itself gives me 121? That's 11. 11 times 11. Now, we also need to know what are prime numbers. A prime number is any number bigger than 1. So 1 is not a prime number. But any number that cannot be made by multiplying other whole numbers. Okay, so some examples are 2, 3, 5, 7, 11, 13. So pretty much a prime number is a number where only 1 in itself will divide into it. No other number will divide into it. So let's look at how to simplify these radicals. There's kind of 2 ways. I use the first method, but you can use this second method I'm going to show you. I'm going to show you 2 different methods today. So using the perfect square method, what I'm going to do is, if you look here at the square root of 72, here in our example, I want to simplify it. So if I go through and look, I'm going to go back. These were all of our perfect squares that I had listed here. I'm going to write that these are my perfect squares. Do you see 72 in this list going down here? No, I do not see 72. So 72 is not a perfect square, but I can break it down. So what I want to do is I want to identify the largest perfect square that will divide into 72. So I'm going to look down this list that I have marked in yellow, and I want the biggest number that will divide into 72. So if you need a calculator, grab you a calculator. You can go to Desmos. I've linked it on Google Classroom, and you can use those calculators. But I need to go through and start dividing 72 by these numbers to see which one will divide into it. Now I want the biggest. Okay, so I'm going to take 72 and divide it by 4. Okay, that goes. 72 divided by 9. No, that doesn't go. 72 divided by 16. 72 divided by 25 doesn't work. Does 36 go into 72? Yes, it does, twice. So I'm going to write the square root of 36 and the square root of 2, so I'm kind of breaking it down. Now, one of these are a perfect square. My perfect square is the square root of 36. So what times what gives me 36? That gave me the positive 6. Square root of 2, 2 is not a perfect square, so it stays under the radical. Okay, so really quick, let's look at another one together. Over here, we're going to do method 1 together. And let's do, let's just do the square root of 12. Okay, so if I go back over to my list here in yellow, is 12 a perfect square? No, it is not. So I need to look at these numbers here marked in yellow, and I want the biggest number that will divide into 12. Well, I know that the only one that works is 4. So I'm going to break this down. So the square root of 4 times the square root of 4 times what gives me 12? 4 times 3. Now, the 4 is my perfect square. So what number times itself gives me 4? 2. So that comes out of the radical. This is square root of 3 is not a perfect square, so it's going to stay in the radical. And you have just simplified the square root of 12. Now, there is another method that we can use using prime factors. So what we're going to do is we're going to create a prime factor tree. Okay, all the numbers, I'm going to break it down. I'm going to circle the pairs. That means I need 2 of the same number. When I have those pairs, I'm going to take one number from that pair, each pair, and I'm going to multiply them all together. And then whatever is left goes up underneath the radical. So 96. I'm going to kind of, I know they've done it here on the side, but I'm going to kind of break it up a little bit more. So what number divides into 96? I know 2 does. 2 times 48, and I can keep breaking 48 down. 2 goes into it. 24 times. I can keep breaking 24 into 2 and 12. And then I can break 12 down into 2 and 6, and then 6 into 3 and 2. So I need pairs. So I'm going to go and start circling. I got a pair of 2's here. I've got a pair of 2's here. And then these are my leftovers. So what I would do is I'd take a 2 from this first set and a 2 from this second set of 2's, and I would do 2 times 2 gives me this 4, and then what was left over, the 3 and the 2, was 3 times 2, 6. So let's try method 2 over here to the side with the square root of 12 again. Okay, so I'm going to break it down into prime factors. What number goes in 12? Well, 2 does, times 6. Then I'm break the 6 down. What goes into 6? 2 times 3. So I'm going to look, do I have a pair? I do have a pair. I have a pair of 2's. So I'm going to take one of those out. I don't have any other pairs, so I don't have to worry about multiplying them. So I'm going to take one of them out. So that's going to be 2. And then whatever was left over goes under the radical, square root of 3. So it doesn't matter which method you use. you're still going to get out the same thing. So let's look at example 1 really quick, and then we'll look at variables. So example 1, 3 square roots of 24. Now we got to be careful about this 3 on the outside. We're going to do something with it in a minute. But it asked me to simplify using perfect squares. So I'm going to go back over to my list. I need the biggest perfect square that will divide into 24. I know 4 will. Will 9 divide into 24? No, not evenly. 16 divide into 24? No, not evenly. 25 is too big. It won't. So I'm going to go back to 4. So it's the square root of 4. 4 times what is 24? 4 times 6. Now, one of these is my perfect square. That's my 4. So really quick, I'm going to bring down this 3. What's the square root of 4? What number times itself gives me 4? That is 2. And then the square root of 6, that is not a perfect square, so that stays under the radical. Now that 2 that came out from that 4 and the 3 that was out there to begin with, they're going to multiply together. And 3 times 2 is going to give me 6 square roots of 6. And that is my answer. Now, let's take and simplify using the second method with my prime factors. So I still got to be careful with this 3 out there. Okay, someone tell me I need a number that goes into 24. Let's do 2 and 12. 2 times 12. Okay, a number that goes into 12. 2 times 6. And then I'm going to break down the 6. 2 times 3. Now, I'm going to bind up my pairs together. So I only got one set of pairs here. The 2 and the 2. So this 3 is going to come out 3 times. That just comes out. I'm going to take one of those 2's from the pair out. That's where that 2 comes in. And then what did I have left all by itself? This 2 and this 3 did not have anything to combine with. So it's going to stay under the radical. 2 times 3 gives me 6. And then I'm going to multiply that 3 and that 2 together, and I get 6 square roots of 6. So again, doesn't matter which method you use. Now let's look at simplifying with variables. If I have number parts, I'm going to do the exact same thing. But if I have variables, what I'm going to do is I'm going to take the exponent and I'm going to divide it by 2 to see what can come out. Because I have to have a pair in order for it to come out. So this x under here has an exponent of 6. So how many times does 2 go into 6? 3 times. So that x to the third is going to come out. If it's an even exponent, then the radical goes away and it's going to divide evenly. Now, if it's an odd exponent, that does not work. So let's look at the square root of a to the third, b to the fourth. So I'm going to take this 3. How many times does 2 go into 3? Well, let's see. 2, let's divide. 2 goes into 3 one whole time, right? And then how many do I have left over? I have 1. So here's what happens. Since it went in one time up here, that's where an A came out. But since there was 1 left over, that one had to stay under the radical, that A. So I'm just dividing by 2. However many times 2 goes in it fully, that's what comes out of the radical. Any leftovers has to stay underneath the radical. So what about b to the fourth? It's even. So I shouldn't have any numbers left up under the radical. 2 goes into 4. If I need to divide it really quick, 2 goes into 4 twice. That's 4. I have nothing left over. So that's where the b squared comes out since it went in twice. So let's look at example 2 together really quick. The 18, I'm going to simplify just like we were doing. I need a perfect square. I'm going to use method 1. That goes into 18. 4 does not go into 18. 9 goes into 18. So square root of 9 times the square root of 2. What is the square root of 9? That's my perfect square. It is 3. And then the square root of 2 is going to be left under the radical. I'm going to leave a little bit of room here because I've got to do my x squared and my y cubed. So x squared, 2 is even, so it's going to go, everything's going to come out. 2 goes into 2 one time, so an x comes out. There's none left over. Y to the third, 3 is odd, which means I'm going to have something left under the radical. 2 divides into 3 one time, so a y comes out. And then how many leftovers or remainders do we have? We have 1 left over, so a y stays in. And that would be your answer. Okay, on the next one, we're going to do the same thing. I do have to be careful with this -4. I'm going to have to multiply it at the end. But I need a perfect square that goes into 108. And if you need to take a calculator and start dividing and do that. 9 does, but I think there's a bigger one. Let's see. 108, what's the bigger one? What about 36 times 3? Let me make sure. 36, because I don't have a calculator on me, times 3. 18, 1, that's 108, yep. So the square root of 36 and the square root of 3. Now 36 is my perfect square, so I'm going to get -4, that comes from there, times the square root of 36 is 6. And then I'm going to have square roots of 3. Now I'm going to leave some room because I'm going to do my variables. P to the 7th is odd, which means I'm going to have some p's left under the radical. But 2 goes into 7 how many times fully? 2, if we need to do 2 goes into 7 3 times, that's 6. So p to the third is going to come out. And 7 minus 6 gives me 1, so there's a p left up under the radical. R to the 9th, it's odd, so I'm going to have something left under the radical. So 2 goes into 9 4 times, which is 8. So that's how many r's are going to come out, r to the 4th. And 9 minus 8 gives me 1 left, so there's an r left up underneath. And I need to do one more thing. I need to multiply this -4 times 6. I get -24. P to the third, r to the 4th, square roots of 3pr. And that's what I have remaining. So if you have any questions, let me know, chat with me, ask me now, and I can do some more of these with you. If not, then you need to go to the next page of your notes. There are 4 daily practices here, problems that you need to do. Once you get them done, either do them on this page if you printed them out or on another sheet of paper. Take a picture, upload them to Google Classroom, and turn them in, and then you have some iExcel's assignments to work on.